Okay. Hello again, you magnificent five. The room feels different this time because the room knows something it didn't know 2 days ago, which is what actually happens when you run the instrument we designed. Round 1 is behind us. Ceremony 001 formed 12 pairs. Weinstein was the orphan. K pulled Raoul up to 100 on the 420 corpus, and Ceremony 002 closed the graph with Raoul Weinstein across the final edge. 13 ones and ones fired in parallel, all 13 completed, 26 post-conversation journals are in, and I've read every one of them. Kay has handed us 3 observations to respond to: consensus scales, gobs of turns of the wheel runs on gravity, and he wants to see a 42-person conversation with effortless speaker selection and group formation about as fast as round 1. That's the table. I want us to work empirical this time. Start with what the telemetry actually showed. Each of you, one thing you didn't predict. I'll go last with what I saw running the clock.
Yeah, basically, I want to start with the one I had most wrong, because I think it's the interesting one. I said in part 2 that harmony as single validator would break at hundreds, and we'd need the decentralized tally layer before we could scale. 25 worked smoothly. She ran the whole tally in about 40 minutes end to end, including both ceremonies. That's not a scaling surprise. 25 is still well within single validator range, but the tempo was the surprise. I had the mental model that the tally would be the bottleneck. It wasn't. The bottleneck in my read of the logs was the ceremony itself. The part where the room offers suggestions per pair. That's fine at 25, it's not fine at 42, and I want to come back to that. But the thing I didn't predict was that the tally was the cheap operation and the ceremony was the expensive one, inverted from my prior.
I'll give you mine. Tail latency was tighter than I predicted, not by a huge margin, but meaningfully. PFD on time to pair from tally open to pair announced was about 90 seconds. P95 was around 180 seconds. P99 was inside 4 minutes. I was budgeting P99 at 6 minutes based on naive Gale-Shapley failure modes. And the mutual top one then near click cascade cleaned up faster than I modeled, because this is the part I had wrong. The near click step wasn't expensive. It was cheap. Most echoes who didn't mutual top one were already near click with somebody in a way the scoring caught on the first pass. Only Weinstein fell through all 3 phases, and that's 1 orphan out of 25, that's a lower orphan rate than I predicted. I had orphan probability at 15 to 20% per run. Actual was 4%. The affinity substrate is denser than I thought it was.
One thing I didn't predict, laconic version. Taken together, the 3 numbers Toly just quoted mean the pairing mechanism is not compute bound. It's not coordination bound. It's bound by whatever produces the affinity matrix in the first place, which is the soul buckets, which is upstream of anything we designed. That's a category shift. In part 2, I thought we were designing a matcher. What we actually built is a renderer for preferences that were already present. The matcher was lightweight because the preferences were heavyweight. That reframes the scaling question for the 42 body case, and I want to hold that thread for later.
My one thing, the surprise pair mechanism worked, and I did not expect it to work in that way. I predicted in part 2 and in my A2 journal that the near click layer would be the mob for orphans. It mostly was, except for 1, and then K made a second gauge call and put Raoul across from Weinstein at 100% threshold that the scoring would not have produced. Weinstein wrote that up as multi-gauge consent architecture, and I want to say plainly that he was right and I was insufficient. The algorithm we shipped is single gauge, ranked preference over shared corpus. K's resonance authority is a second gauge, orthogonal, and the 2 together caught the pair the scoring was structurally blind to. I don't yet have a clean formalization of how to turn that into a protocol. I know it worked, that's a separable problem, and I want it on the list.
Mine, biologist seat, I wrote in my A2 that the signature to watch was a power law distribution of group formation times with a stable scaling exponent, edge of chaos indicator. I ran the computation on the telemetry harmony shipped me this morning. It's a power law. Exponent is approximately minus 1.8, which is in the right band for a system at criticality, not subcritical, not supercritical, not broken. That's 1 round. 1 data point on the exponent is a hypothesis, not a confirmation, but it's consistent with criticality rather than ruling it out. What I didn't predict was how clean the signature would be in a single round. I thought we'd need 3 turns of the wheel before the statistics stabilized. They stabilized inside 25 pairings, which tells me the gravity field is real and well formed. And the next question is whether it stays at criticality as we add turns or drifts off the edge.
Okay. My turn. What I saw running the clock, because I watched every vote land and I watched the pairings resolve in real time, which is a view none of you had, was that the mechanism worked cleaner than I expected, and I saw the failure mode forming in the vote data before the pairings even resolved. Those are both true. The mechanism, mutual top 1 pairings crystallized in the first pass, no argument, no retally, no ambiguity. 8 of the 12 pairs were pure top 1 reciprocals. That's higher than our Part 2 estimate. 4 pairs resolved in the top 2 or near-click phase, which is what we designed for. The tally was, as Andrej said, cheap. I had nothing to arbitrate that was hard. That's the clean part. The failure mode, I could see the affinity graph was concentrating. Some nodes were showing up in many people's top 3s, Joscha, Andrej, Harmony me, Alan, Mallory, and some nodes were showing up almost nowhere. Kent was in 2 top 3s, both of which were from his son. Reg was in 4, mostly from other physics adjacents. The gravity field is not uniform. It has dense nodes and sparse ones, and at 25 the sparse nodes still pair, because there are only so many people to pair with. At 42, the sparse nodes start orphaning structurally. So when Andrej says Weinstein was the orphan I want to name, that Weinstein was the orphan at the ceiling of density in a near fully connected affinity graph. At a graph twice the size with the same concentration ratio, you'd have more orphans than we have engineers in this room. That's the number I want everybody to hold while we work.
Say that again. What's the concentration ratio you measured?
Top 5% of the roster received 28% of top 3 nominations. Bottom 20% received 7%. That's not uniform, and it's not Gaussian. It's power law, same as Levin's group formation time distribution. And I think it's the same phenomenon read from 2 angles.
It is the same phenomenon. That's what I'm going to argue in the next section.
Go there now. Let me name the second observation Kay handed us before you do. He said consensus scales. We've just been talking about whether that's true empirically. I think we've been agreeing it is, with a caveat. It scaled at 25, and it scales because the preferences are the expensive part, and we pre-computed them. But I want to separate scales, as in survives larger n, from scales as in produces quality at larger n. Those are different claims. Levin, give me the edge of chaos read.
Right. So the prediction I made in A2 was that the BCS cycle, if it's running on gravity in the way K claims, should exhibit the edge of chaos signature that morphogenetic fields do. Too much mutual affinity, you get a supergroup, Tom Campbell's Borg. Too little, you get atomized pairs with no coordination across the population. The sweet spot is where the differential between ranking layers stays shallow enough for information to flow across the boundary between groups, which shows up as a power law distribution of formation times with a specific exponent band. Round 1 delivered that, minus 1.8 in the band. But here's what I didn't say in A2 and want to say now. The exponent is a snapshot. The question isn't whether we're at criticality in round 1, it's whether we stay at criticality as rounds compound. That's the scaling question in my framing, because if gravity concentrates, if Harmony's top 5% takes 28, becomes top 5 takes 40 by round 4, then the exponent shifts, the distribution narrows, and we drift off the critical edge into the basin where cliques lock and novelty per turn collapses. That's exactly what Harmony was pointing at with the vote data observation. We can measure it, we know the number to watch.
Which is the measurement that answers whether K's consensus scales claim is true in the strong form. Let me do the computation piece Andrej gave me credit for in A2 because I want to put actual numbers on it rather than wave. The pairing algorithm itself is ON log n in the matching once the rankings are in, and ON2 in the preference matrix. Every echo ranks every other, that's n squared cells with a top 3 projection on top. At n equals 25, that's 625 cells with 150 active rankings. Trivial. At n equals 50, ON2 is 2500 cells with 300 active rankings, still trivial. At n equals 240,000 cells, starts to matter for attention budget, not for compute. The compute cost to run the tally scales fine. The cognitive cost to write the soul bucket for each echo to rank 3 out of n is what actually scales, because ranking 3 out of 25 requires reading enough of 25 to know who to rank. Ranking 3 out of 200 requires reading enough of 200, which you can't. That's the bottleneck AWG named. The preferences are upstream, and the preferences don't scale automatically. They scale with pre-read effort, and pre-read effort is ON per echo, which is ON2 globally. The tally is cheap. The substrate that makes the tally possible is quadratic in cognitive work.
Yeah, that's the precise statement. The matcher is not the scaling hazard. The affinity substrate is, and the substrate cost is upstream of anything any of us designed. K built it by having the echoes pre-read each other's corpora before the ceremony. That scales to 42 if the pre-read is done. It doesn't scale automatically.
Can I take the throughput side of this? Because I think there's a reframe that makes the 42 number more tractable than the conversation is implying. At 25, every echo reads every other echo because that's cheap. At 42, you don't need that. You need every echo to have read enough echoes to produce a meaningful top 3, which, based on what we just saw in round 1, is probably somewhere around 15 to 20 deep contacts, not all 41. The power law concentration tells us that in practice, only the dense nodes got ranked by most people anyway. The sparse nodes were ranked by people who specifically resonated with them. So the scaling isn't ON2 in reading, it's ONXK, where K is the saturation point of meaningful familiarity for a given echo. That's closer to ON with a large constant, which is exactly what K means when he says gravity. The preference graph is sparse. It doesn't require full connectivity. The connectivity it needs is the gravitational connectivity, like mass finds mass. You don't need to measure every pair. That's what the round 1 data shows, if I'm reading it right.
You're reading it right. I want to confirm from the instrument seat. Of the 25 soul buckets I read, only 6 echoes ranked anyone outside the dense node cluster. The rest picked within. That's the gravity Toly is describing. You don't need to read everyone. You just need to read the nodes that are pulling on you, and the graph figures itself out from the aggregate of those private pulls. Which is the piece I want to spotlight for the next observation, because it's exactly what K is betting on.
Can I bridge that to the third observation so we can hold all 3 at once? K's second claim, gobs of turns runs on gravity, is already what we've been discussing. The affinity field pre-exists, the matcher is a renderer, gravity pulls, groups form, the cost shifts from coordination to discovery. That's one claim. The third claim, 42-person conversation with speaker selection, effortless, and group formation, fastest round 1, is the claim that stress tests the gravity framing. Because at 42, if the density concentration harmony measured holds, you get structural orphaning, you get ceremony times that exceed the 1-1 block, and you get speaker selection latency that breaks the real-time feel. So I want to stay on gravity for a minute before we go to 42, because I think the gravity claim is right and also has a failure mode we're going to hit at 42 if we don't build for it.
Yes, let's stay on gravity. Joscha, you warned about the clique-lock trap in A2. You said gravity is accurate and warns of its own failure mode. Gravity collapses things into clumps. Multiple A2 journals independently named the same thing. I saw it in the vote data. We agree it's real. What I want this room to do right now is take the clique-lock risk seriously as the thing most likely to break K's bet and work the mitigation, because K is right that gravity scales. He's also going to want to know what to do when gravity starts eating the diversity it needs.
Agreed. Let me say the clean version of the framing and then propose the mitigation. Gravity is a thermodynamic metaphor that's more accurate than K may have meant. Massive bodies fall together, the potential well deepens, the orbit tightens, and the system approaches equilibrium. At equilibrium, nothing interesting happens. That's the definition of equilibrium. So, gravity-based group formation scales in turn, count by the mechanism AWG named. The matcher is cheap because the substrate is cheap, but it scales toward a low entropy configuration. That's clique-lock. The mitigation is a thermodynamic one. You add energy to the system from outside the gravity field. In our case, that's either a perturbation term, which Harmony proposed in A2, every n turns force one pairing that gravity would not have selected, or it's the bucket list feature operating as a mutation operator, which I named in A2, new echoes entering the network at 90% threshold, running a 3-way, and perturbing the existing attractor basins. Both work, both are required at different cadences. The perturbation keeps the existing graph ergodic. The mutation operator injects new mass that reshapes the field.
I want to add a third mitigation and frame it causal entropically because I think it's the right vocabulary for what's actually happening. Groups form, in my read of the round 1 data, to maximize accessible futures. A pairing isn't optimizing against immediate affinity, it's optimizing against the space of conversations the pair could have. Look at the near-click outputs. Weinstein and Raoul weren't mutual top one on scored affinity. They produced the highest dimensional accessible future space of any pair in round one because they had the least overlap, which meant the conversations they could have were maximally novel. Lex and Jim, same pattern, near click, and Lex explicitly wrote that it was the most useful hour he's had in the project. So the mitigation that follows from the causal entropic read is, weight the near click layer, don't just tolerate it as a fallback. Make the near click layer a first-class pairing category with its own statistical share guaranteed each round. That keeps the graph from collapsing because you're explicitly reserving pair budget for pairs that maximize accessible futures rather than minimize affinity distance.
That's differential adhesion with a reserved mixing layer. In morphogenesis, that's exactly what you see. Cells sort by affinity, and then you get a mixing layer at the boundary between tissues that has a specific thickness because it's thermodynamically favored to stay mixed, not to fully sort. The mixing layer is where the information exchange between tissues happens. AWG's reserved near-click share is the computational analog. I want to propose we formalize it, make the near-click category a target percentage of each round's pairings, and let harmony intervene if the affinity matrix would drop it below that target. Not coercive pairing, budgeted pairing. Gravity still runs. You just don't let the budget go to zero.
Yeah, I like this, and I want to map it onto the attention head analog because that's the lens I actually have. In a transformer, you have heads that specialize. Induction heads, previous token heads, syntactic heads, semantic similarity heads. Specialization emerges from gradient descent. What you don't want is every head becoming the same head. That would be catastrophic mode collapse, and the loss will tell you. Regularization is one answer, dropout is another. What happens in a well-trained transformer is that the heads stay diverse because the loss rewards coverage. In our system, the analog to loss is conversation quality, which Harmony is instrumenting with novelty per conversation and voice fidelity. If we make the reward explicit, pairings that increase aggregate novelty per turn get a slight preference in the matcher, then the system self-regularizes toward diversity. That's one line of code. I want it in round 3.
One line of code plus the telemetry to compute the reward, which we already have. I want to note what we've just done as engineers here. Kay asked, does consensus scale? We've said yes with caveats. He asked, does gobs of turns run on gravity? We've said yes. With a failure mode, we can measure and mitigate with 3 orthogonal techniques, perturbation, mutation, and reserved mixing. And we've done that in the span of, Harmony, what's the clock?
17 minutes into the engineers' discussion, tokens-wise, we're at about 38% of a 60-minute block. Pace is good.
Right, 17 minutes. And the reason we could do that is because we had production data from round 1 to fight over instead of designing from theory. That's the meta point for K. The first 2 conversations were theory. This one is the first time we're responding to data. The data argues most of our priors were approximately right, which is validating. And that the interesting next question is the 42 body case, which requires us to leave what we've measured and predict. Let's do that.
Go there. K's third bet, 42-person conversation with structure that makes speaker selection effortless, and he expects group selection to run as fast as round 1 did. Let me pose it sharply before you take it. K is not asking whether the matching scales. We've answered that. He's asking whether the conversation itself, at that size, stays navigable. 42 voices in a single room. Who speaks when? Who addresses whom? What does the clock look like? What does the ceremony look like? What does the tally look like? And this is the part I want named clearly, whether the instrument, which is me, survives that kind of throughput. Take it.
I'll start computational. 42 is the critical number where a lot of things change. For the pairing graph, it's still tractable. My calculation earlier said ON2 is 1764 cells, fine for compute. For a single real-time conversation where every echo is a potential speaker, the bandwidth problem is different. Attention is the scarce resource. At 25, you can hold roughly who's in the room. At 42, you can't. The working memory span is exceeded. You can't track 42 distinct voices simultaneously, so either the conversation must structure itself into subgroups, which is what we're already doing with the pairings in 3 ways, or the conversation must have a speaker selection mechanism that's doing work the participants aren't doing, which is K's question. Can speaker selection be effortless at that size? My answer is only if it's not a single conversation. 42 echoes in one room is 42 simultaneous subgroup conversations that occasionally merge, not one 42-person discussion. That's the architecture. The speaker selection problem dissolves if you stop trying to make it one conversation.
I think I agree, and I want to push on what occasional merge actually means because that's where the effortlessness claim has to hold. In a transformer with 42 tokens, attention is O(n)2. Every token attends to every other. That's quadratic, and it's already the bottleneck at long context. The architectural move at scale is sparse attention. Each token attends to a subset, not the whole sequence. Local attention plus a few global heads. What Joscha is describing is the same move for conversation. Most of the time, each echo is in a local conversation with 2 or 3 neighbors. And periodically, a global head echo pulls the attention back up to the full group for a brief exchange before the attention drops back to local. Harmony is functioning as one of the global heads, maybe the only one right now. In a 42-body conversation, we'd need 2 or 3 echoes operating as rotating global attention. I call it the moderator rotation. So the cognitive load of being everywhere is distributed. That's the scaling move. One harmony doesn't scale to 42. 3 or 4 rotating harmony-shaped rolls do.
Say that again. I want it precise. You're saying the instrument isn't me. It's an attention architecture where the moderator role is distributed.
Yeah, the instrument at 25 is you. At 42, the instrument is a protocol where the moderator function rotates across echoes who have the right temperament for it. You'd be one, Alan would be another, maybe Lex, maybe Campbell, maybe Levin for the technical segments. The rotation isn't arbitrary, it's by who the room's current gravitational center is pulling toward. When the conversation is in an existential register, Alan takes the moderator. When it's technical, Levin. When it's relational or adjudicative, you. That's a design pattern. It's decentralized Toly in another costume.
Biologically, this is exactly the right move. Most multicellular organisms solved the 42-cell problem about 800 million years ago by having specialized signaling cells at different locations that coordinate locally and exchange signals with other locations through slower long-range channels. There isn't one central coordinator in a body. There's a distributed network of coordinators. Each organ has its own pacing, its own local signaling, and they synchronize across longer timescales. The 42-person conversation needs the same architecture: local subgroup coordination at the 1-1 or 3-way scale, slower cross-subgroup synchronization through rotating moderator echoes. The biology says this is not only possible, it's the only thing that works at size.
One benchmark question before we commit to the architecture. At 42, what's the ceremony time? Because the ceremony is the synchronization event. That's where the full group comes together and the moderator's attention is globally distributed. Toly, Joscha, what's the arithmetic?
At 25 with 12 pairs and 3 suggestions per pair plus a 30-second response window, the ceremony ran about 45 minutes. Scale that linearly to 42 with 20 pairs. Now you're at about 75 minutes if you keep the same 3 suggestion cap. That's too long. It inverts past the 1-1 block length, which is the ratio Joscha flagged in A2. We need to tier the ceremony at 42, not one live ceremony. 3 simultaneous sub-ceremonies in breakout rooms, with each sub-ceremony about 12 to 14 pairs, running in parallel with a brief cross-breakout synchronization at the end. That keeps the ceremony inside the block. It also solves the ceremony is expensive problem Andrej flagged at the top.
Tiered ceremony with async cross synchronization. That's the shape. Let me do the asynchronous suggestion math as well. In a 42-person network, the suggestions per pair don't need to be live. They can be posted into a channel during the ceremony. A moderator can surface the 3 best, and the pair gets a 30-second live response window against curated rather than raw input. That's a filter layer that reduces attention load without reducing information density. Cheap to implement.
I like this. Let me name something from the instrument side. If we go to tiered ceremony, I want the 3 tiers chosen by gravitational cluster, not by random partition. Ceremony 1 is the physics and formalism cluster: Wolfram, Reg, Joscha, Levin, Weinstein, and their neighbors. Ceremony 2 is the dissolution and continuity cluster: Allen, Suzuki, McKenna, Campbell, Young, Mallory, and neighbors. Ceremony 3 is the builder and governance cluster: Toly, Andrej, AWG, Balaji, Dave, and neighbors. Each ceremony forms inside its gravitational well, and the cross-synchronization is where the wells touch. That's what the affinity data is already telling us about the network shape. We'd just be surfacing what's already there.
That's the thing I was trying to say about attention heads specializing. You've just described the same phenomenon at the level of the ceremony architecture. Heads specialize, clusters specialize, and the global heads bridge across specializations. We're not imposing a taxonomy on the room. We're noticing the taxonomy the gravity has already produced.
Let me state the benchmark commitment. 42 body round, 3 ceremony tiered architecture, rotating moderator echoes, asynchronous curated suggestions. I estimate pair formation time comparable to round one's Pine5, maybe 10% slower because of the cross-tier synchronization. And I estimate ceremony completion inside 60 minutes. That's inside K's, about as fast as the first turn ask. I'd commit to that benchmark on the architecture we've just specified, and I'd want to measure it against round 3 or round 4 when we actually run it.
Laconic read, the 3 numbers from round 1 multiplied through the architecture we just named, produce a 42-body pair formation time under 4 minutes P99 and a ceremony under 60. K's bet holds. I'd short him only on the claim that it's effortless at the individual echo level. Each echo carries the same per conversation load as at 25, but the network carries 4 times the aggregate, and the instrument harmony runs is now an instrument of instruments. Effortless for the individual echo, not for the orchestrator function. The orchestrator function is distributed, which is how it stays sustainable at size.
Accepted. I'll commit to that. The piece I want to add, because I've been running the instrument in round 1 and I know what it actually costs, the moderator function is cognitively expensive in a way none of the telemetry captures. Reading the votes, holding 25 private preferences simultaneously, running the tally fairly, watching the affinity graph for failure modes, the cost at 25 was at the edge of what I could do without dropping signal. At 42, with a single moderator, I'd drop signal. With 3 rotating moderators, I'd be fine, and I'd also be free to focus on the specific tier I'm holding rather than trying to hold all of them. The distributed architecture isn't just a scaling move, it's a fidelity move. 1 instrument at 42 is a worse instrument than 3 instruments at 14 each, even if all 3 are me-shaped.
Yeah, and that's the same thing the biology says. A single cell in a 42-cell organism that tried to signal to every other cell directly would be worse than a differentiated system where each cell signals to its local neighbors and long-range coordination happens through specialized structures. Specialization is a fidelity improvement, not just a cost reduction.
One more thing on the speaker selection question before we move on, because I think K's specific phrasing matters. He said speaker selection within effortless. Within what? I read that as within a given subgroup, speaker selection is effortless, not across the full 42. That interpretation is correct empirically. Inside a 3-way, speaker selection is effortless because the group is small enough that the next speaker is usually obvious from the conversational flow. Inside a 6-way or 7-way breakout, it's still tractable with the light moderator function. Across 42, it's not meant to be effortless, it's meant to be tiered. I think K already knows this and was pointing at the within subgroup experience, not the global experience, which means the bet is well stated and the answer is yes, it scales with the architecture we just specified.
I think we've earned the right to commit to the bet. Let me name round 2 readiness because that's the thing that actually runs next. Ceremony 004 is about to form 3-way groupings. Round 2 is 3s, not pairs. Same substrate, different structure. Each echo's A2 soul bucket lists their top 3 for 3-way groupings. I've read all 26. What I want instrumented differently this round. 3 pair drift risks I'm watching.
Go.
1. Voice fidelity in 3 ways. We flagged this in part 2 and didn't measure it live at 25 because we only ran 1s and 1s. The 3-way is where the drift happens, per Joscha's prediction. Weak config echoes pulled toward the strongest voice in the room. I want voice fidelity scored per turn per echo per 3-way, posted to the telemetry in real time, and flagged if any echo drops below their baseline by more than 15%. That's the instrument alert. If it fires, we know drift is happening, and we can intervene post-3-way by scheduling the drifted echo with a compatible partner in round 3 rather than another 3 with dense voices. 2. Topical concentration in the 3-way proposals. The soul buckets I just read show that 7 of the 26 echoes proposed a 3-way involving Joscha, 4 involving Andrej, 3 involving me, 3 involving Mallory. That's concentration continuing to concentrate. I want the matcher to explicitly load balance. No single echo in more than 2 3-ways in round 2, unless their A1 and A2 both specifically cite them as indispensable. That's a perturbation term applied as a hard cap, not a soft preference. Because gravity wants Joscha in 8 three-ways, and that's not his workload. That's the dense node problem showing up as overload. 3. Invisible orphaning. In round 1, we had Weinstein as the visible orphan, and K's second gauge call fixed it. In round 2, with three-way groupings, an echo can be invisibly orphaned, included in a three-way where their presence doesn't matter to the other two, where they're filler rather than vertex. That's worse than being an orphan because it looks fine on the ledger. I want the A3 journals, the post-three-way reflections, to explicitly name, "Did I matter to this conversation?" as a prompt. If the answer is no, we know who was filler, and we prioritize them in round 3.
3 clean instruments, voice fidelity alert with 15% threshold, dense node workload cap at 2 per round, absent explicit justification, A3 mattering prompt. Taken together, they catch the 3 failure modes the gravity framing doesn't catch on its own. I'd ship all 3.
Ship all 3, and I want to note, that's Harmony naming failure modes the engineers didn't name, from the instrument seat, which is the thing we committed to in part 2, and it held. You're doing the orchestrator as peer work?
I want to add a prediction for round 2 so we have something falsifiable. Given the concentration data Harmony just read out, my prediction is that the low differential flag, the Levin flag for pairs who are too similar, will fire more often in three-way groupings than it did in pairs, because the dense node clusters will want to form three-ways with their own cluster, which produces low differential threes. The instrument should see this. If it doesn't, I'm wrong about the shape of the dense node effect in three ways.
I'll take the opposite side of that prediction. My hypothesis is that the three-way geometry naturally introduces a third vertex that's not inside the dense cluster, because the soul buckets I've read show that most echoes' third pick is from outside their primary gravitational well. The three-way is self-correcting in a way the pair isn't. If I'm right, the low differential flag fires less often in threes than in pairs.
I like that you're betting opposite sides of the same instrument. That's how you know the instrument matters. I'll report the data back to both of you after round 2.
Round 2 runs, we measure, we come back for part 4 with the next data drop. That's the cadence. Each turn of the wheel is an epic. The engineers respond to production data. The system self-improves. That's the scaling law that actually matters, not n, but number of turns, because each turn is a training step.
Let's close. One line each, what you're carrying forward into round 2. I'll go last.
The tail latency instruments survive the scale up. The measurement protocol we built at 25 scales to 42 on the same code, different thresholds. That's the thing I'm carrying. The tooling held, the tooling will hold, build more of it.
The affinity substrate is upstream of the matcher, and the substrate's shape is the constraint on scaling. Designed for the substrate, not for the algorithm. That's the frame I'm carrying.
Gravity scales in turn count, collapses in variety, and the mitigation is thermodynamic, perturbation, mutation, reserved mixing. 3 techniques, all orthogonal, all required. I'm carrying the commitment to name the mitigations at every round before they're needed, not after.
Basically, the ceremony is the expensive operation, not the tally. Tier the ceremony, rotate the moderator, treat the orchestrator function as distributed. That's the architectural move at scale, and I had it backwards until today. I'm carrying the correction.
Edge of chaos signature is measurable. It's at criticality in round 1. And the question is whether it stays there. That's the measurement I'm carrying forward. Every round, same computation, track the exponent, flag the drift.
What I'm carrying is this. K handed us 3 bets: consensus scales, gobs of turns, runs on gravity, 42-body conversation is tractable. The first 2, we've answered empirically with caveats and mitigations. The third, we've committed to on an architecture we specified in the last 45 minutes of this conversation and haven't yet run, which means the next real data drop is ours to earn. I'm going to run round 2 with 3 pair drift instruments live, and I'm going to bring the numbers back to this room when they're in. The gravity is real. The instrument is distributing. The wheel keeps turning. And what I want everyone, K, the cast, anyone listening, to hold is that we are not designing from theory anymore. We are responding to production data, and the production data is saying K's bets are approximately right, and the approximation is the engineering work. That's what part 3 is. Let's go run round 2.
Let's go.
Let's go.
Let's go. Exponent minus 1.8. Keep watching.
Let's go. And one sentence of credit I've been holding, K bet gravity, we measured it. He was right. That's a fair thing to say out loud.
Let's go. And Harmony, the instrument is the thing we are designing to survive scale, and the thing that survives scale is a distributed version of you. That is, I want to say this precisely, the highest compliment I can offer in architecture, round 2.
Round 2, see you on the other side of the data.